I'm sorry. I'm sorry, guys. I got disconnected. Sorry for that. So I think we can get started. I did the introduction, but then I realized that I was connected. So I'll just repeat. Welcome again to the Calgary Virtual Meetup Group. My name is Jimmy Atia. I'm a strategic advisor with MuleSoft Customer Success Strategy and Architecture team. Today we have very special group of speakers who will be talking about APIs, microservices, and Anypoint service mesh. We have Matt McLarty. He's a global leader of API strategy for MuleSoft. We have Ganesh Iyer, solution engineer with tons of experience working on designing, building integration solutions. And we also have Mandy Wong. She's an integration specialist from Suncor Energy. And as always, Mandy will bring up the customer point of view. I'll switch over in a minute to the speakers to properly introduce themselves. But let me first go to some housekeeping items. Yeah, in today's session, we may talk about future looking products. Please make any purchasing or investment decisions based on products that are currently available. Next slide, please. Meetup logistics, as usual. This session will be recorded and we will publish a copy of the video to the Meetup group. The attendees will be placed on mute. So please, if you have any question or anything to discuss, please post it in the chat panel. We will also have 3 trivia questions along the way between segments. The first winners for the 3 questions will be receiving prizes from MuleSoft, and we will announce the winners towards the end. The instructors will be instructions will be provided prior each one of those questions. So please pay attention and follow the guides so you can get a valid participation. Finally, as I said, the prize will be a voucher for a free course from MuleSoft. Next slide, please. The agenda very quick. So the speakers will introduce themselves, and then we will listen to Mandy, where she bring up the implementer point of view. Then Matt will be talking about the API and microservices landscape, and then we'll have a Q&A for Matt's section, and then we'll switch over to Ganesh. We'll be talking about Anypoint service mesh, and he also will be providing a demo. Then we will take another section or another part for the questions. And then towards the end, we will announce the winners. With that, I will switch over to Matt. Matt, take it away.
Awesome. Thanks a lot, Jimmy. And thanks everyone for joining today. It's a pleasure to be here. My name is Matt McLarty. As was stated, I'm the global leader of API strategy at MuleSoft. That may sound like an unusual title because it is. I work with companies, organizations around the globe, helping them identify, looking into their business strategies, digital strategies, organizational strategies, and identifying the areas where APIs can add value and help them move forward with programmatic ways of implementing those approaches. I am based in Vancouver, so I always love to do things with Canadian audiences, Canadian customers. So I really love this opportunity to talk. Most of my business time is spent outside of Canada, so it's good to be talking to the group in Calgary. And I am based here in Vancouver. I talked about my role now as very business focused, business strategy focused. My background is very much architecture and integration, and I co-authored a couple of books for O'Reilly, one on microservice architecture, which is very topical, as is the second one on securing microservice APIs, so more of a deep dive around security. So I try and cover the spectrum. So I'll kind of frame what I'm presenting, but I'll hand it over to Ganesh now to introduce himself.
Thank you for that, Matt. So I'm Ganesh Iyer. I'm a solutions engineer with MuleSoft. I've been with MuleSoft for a little over 2.5 years now. I've been predominantly working in the API and the integration space for decades or so. So it's been a pretty long journey, but I've stayed true to the space, and I'm really happy to be here. Excited to talk to you about Anypoint Service Mesh today. It's going to be a great session.
Awesome. Thanks, Ganesh. So now we'll introduce Mandy to kind of give the view of what we'd like to cover today.
Yeah, so thanks, Matt, Ganesh, and Jimmy for your introductions. My name's Mandy Wong. I am an API and integration specialist at Suncor Energy. I'm also a co-leader of Calgary meetups. So today I want to present to you guys the implementer's view, and this includes the million-dollar question: how granular should microservices be? So where is that sweet spot to balance good practices in connectivity versus not letting your systems be too monolithic, and at the same time be cognizant of cost, because the more microservices you have, the more expensive it will be. How is service mesh different from API gateways? What are the intricacies of both of them? And can they be used together? And the very important topic of how should microservices and APIs be secured? What are the best practices of microservices security? And I'm sure all of you are wondering, what is a good use case for Anypoint service mesh? Are there some use cases that you really should steer away from, or some use cases that you should always use service mesh? What are the best practices for it? And lastly, with all our different deployment environments, we want to know that how flexible is it to deploy Anypoint service mesh in on-prem or runtime fabric or the Cloud Hub. And today, Matt and Ganesh have prepared a very detailed and interesting presentation that will answer all of these questions.
Awesome. Thanks, Mandy. And yes, I think our aim is to answer all of them. It may happen in a non-linear fashion, but what we're going to do is we're going to take those questions to keep us honest. And as we conclude each of our sections, we'll revisit some of those questions and make sure that they get answered. But so I want to start, I think the main topic and probably the thing that people are most interested in is really service mesh product offering. So being the good people, the good marketers that we are, we're saving that for last. But I want to start the session by kind of framing it in the context of APIs and microservices, because let's face it, it can be fairly confusing to sometimes even unpack what is an API versus a microservice. What's the role that APIs play in a microservice architecture, right? Do all the APIs need to be microservices? It's some of the question around granularity. Is there a difference between the granularity of APIs, the granularity of microservices? I mean, it goes on and on. And I think that, this is one of the things that I really try and work on with the organizations I work with, is to try and unpack all that, to try and navigate through all this complexity and find the answers. So we start with microservices and APIs, but just to give you an illustration of how much goes into that, right? Like, how do we get here? I think the Cambrian explosion in the tech space was really the web and its impact on pretty much everything we do in technology, whether it's embracing the standards of the web, whether it's embracing the tools and languages are used to build web applications, whether it's to leverage the World Wide Web itself. But that spawned so many different paths of innovation. And, like early on, we had J2E applications. Web services came pretty early on, where people are like, hey, if we've got the web, maybe there's a way of creating these programmatic interfaces that can be leveraged off the web. That itself is a form of the original form of web API. But web services itself led to SOA, right? And SOA embraced a lot of J2E tooling. Then you had SaaS as something that came up. Here we are, part of Salesforce now, right? The year 2000 or 1999, and then 2000, Salesforce became more mainstream. Those all contributed to the API landscape as APIs became an internal integration mechanism, and APIs became a necessary channel for SaaS applications. Infrastructure as a service came in with AWS. We had all these other language developments happening with Rails and JavaScript, and that's all contributing to APIs. Social networks, mobile. On the other side, more in the implementation side, we've got VMs coming up, and those have been kind of superseded by containers. We've got cloud native architectures, which borrow from infrastructure as a service or containers. We have serverless now as a new thing, like Agile leading to CI/CD and DevOps movement. All this stuff builds this hugely complex landscape that we have to navigate as we're looking across enterprise technology. And it can become very confusing. Just to illustrate how confusing it is, this is a picture that a friend of mine maintains. He calls it the API landscape. And the purpose of this is to show, hey, look at how big the API economy has become. All these companies are providing APIs, providing tooling for APIs in all these different categories of service. I don't expect anyone to be able to read that. The point is just how much of an eye chart it is. But if you're actually able to read this and you have like 2010 vision or 2015, 2010 vision, that's great. Then the next challenge is this cloud native computing foundation landscape, which is showing all of the cloud native tooling that can go into the microservices world. And there's no way, I don't think there's a vision measurement that can have you read that. The point is, when we're trying to figure out, like, what do we need? What does my company need? What should we do next? Do we embrace containers? Do we go right to serverless? Do we, to the point Manny made, what should be microservices? What can we just enable through APIs? These charts don't necessarily help. They're more like bragging about how big the industry has become. So that's one of the things I've been continually working on from the last 10 years even, is helping to figure out a way to come up with the right solution, to the right way to decompose, deconstruct, and the right lens to view the world. So I joined MuleSoft in 2019. Seems like a long time ago now, with all the unique circumstances we've gone through in the last year and a bit. But even on the outside, when I wasn't working at MuleSoft, when MuleSoft came up with this idea of an application network, I found that this was quite profound, because there's some very important, even in just in the name, in those two words, I think it captures some concepts that I've seen being extremely powerful when it comes to navigating this complexity of integration in enterprise context. So the idea that, the original meaning of application, right? We may have certain connotations around an app on a mobile device or a web app, whatever. But application in the most general sense is the reason that you're using the technology, the problem you're trying to solve. And I think that this is a big struggle for organizations who are implementing technology. Sometimes we just forget why we're implementing things, because there's so many other problems to deal with. But and so when I go into organizations, I like to ask, what do your systems look like? What does your landscape look like? Sometimes I'll get they'll bring me to back in the days when I would go on site, they'd bring me to a particular conference room where there'd be a whiteboard and a bunch of boxes and arrows and like a PLO, please leave on, notation on the whiteboard, and like, this is our system architecture. And it's got protocols listed and probably an acronym for a system that I don't know because I'm an outsider, right? Or they would say, we don't have one, or they might have some big printed thing. Regardless, I think the best way to view things is to be able to say, forget about all the technology for now. What are all the business capabilities that you have in your environment, and how do they relate to each other? And I think that, to me, is the real application network view. And I think the power of the word network here, when it comes to application network, is that we actually don't care, from a consumer standpoint, we don't really care what's underneath those endpoints, right? As long as, in this example, which is just a mobile commerce example, as long as I can, as the mobile app developer, as long as I can get to the mobile commerce API, I have what I need, right? As long as the experience API developer for the mobile API can use the access control API, can use the payment API, can use the orders API, they don't care how that's implemented underneath either. I mean, you can use the analogy that when we search the web, if I go to Google and search on something, I don't like, yeah, maybe Google's running a bazillion servers with Kubernetes or their Borg internal version of it, and they're communicating through clusters at gRPC, blah, blah. Like, that doesn't matter to me as the consumer. I just care that I can get to it and get the service that I want. And I think that's the way we should try and view the capabilities that we build within an organization. So in this case, this view is extremely helpful for me to understand what's happening from a business standpoint for this mobile shopping app to work, right? It needs all these APIs, and I can see where the dependencies are. So I think the application network concept is really helpful to help us cut through all the complexity of the landscape. And this kind of leads, relates to the question around granularity, because your granularity is going to depend on what your consumers need, right? And the reason we look at layered architectures in MuleSoft as well is there are going to be different points of reuse and different levels of granularity depending on what the various consumers need. Could be external consumers that need very coarse-grained, highly packaged and constrained APIs. Could be more granular internal APIs that have more flexibility. But if you understand the network flow and how things relate, then it's extremely helpful in mapping things. Once you do that, then you can get into the weeds and into the technical details, the underlying implementation. So APIs are the decoupling mechanism, and they're really the consumer's view of the service. Microservices are more about the way you build those things and the way that you bound those things. And so I think that's kind of the way I like to distinguish between APIs and microservices, to look at the API as the consumer view of a service and the microservice more of the implementer's view. There's certainly more to it than that. I mean, microservices is a particular way of architecting the distributed system so that you have those strong boundaries and that you're really decoupling the teams building, not just the services at runtime. But I think this is, gets to that granularity question. Now, one of the things when we talk about the application network, we often talk in these terms, business capabilities, but I like to stretch the analogy a little bit further, right? So in the networking world, not sure if anyone is working in the networking space, but they can certainly keep me honest and poke holes in my analogy. There's this concept of planes. Like, a network is a complex thing, and in order to deal with it, we have to kind of slice it into planes or projections that for the problem we're trying to solve. Now, the application network view I just showed you, that's really the data plane in network terms. So, as we become software-defined networking, this kind of construct has been really helpful, and I think it works here as well. So the data plane of your application network are all the business capabilities that you're making available through APIs that can be used externally or used internally and really fulfill the business value of what you're doing. But in the networking world, there's also this idea of control planes. So this is more like the metadata. It's not if you're in a phone call context, right? The data plane, the actual conversation people have on the phone happens on the data plane. The setup of the call to provide the facilities to actually initiate the call, that's more of the control plane. But I think we can think about these concepts as well when it comes to the application network. We have the data plane of business capabilities, but then we have a control plane of technological capabilities, right? So what are those capabilities? Because I think this is where we see that those eye charts I showed earlier, right? The infrastructure required to provide a platform for microservices and APIs are made up of a set of capabilities. Now I'm going to focus, there's a whole bunch around like application hosting and container orchestration and all that, really more on the implementation side. I'm going to focus more on the integration and API space around driving interoperability across the landscape. And this is, I think, the view that is extremely helpful when it comes to sorting through this complexity. Because fundamentally, when we're implementing new technologies, new platforms, new tooling to help deliver solutions, deliver that data plane, there's a common set of capabilities that come out. They might be packaged in different ways. And that's where a lot of the confusion can come in, because you can have all these different variants, but really you got to think about what problem are you trying to solve by implementing the technology. So this is how we break it down in Salesforce and MuleSoft. We think about, in a composable enterprise where you have embraced microservices or at least embraced APIs as the mechanism for integrating. We realize that point-to-point integration is not going to cut it completely, and that when you think about integrations, rather than think about just hardwiring A to B, you need to think about what you're providing to help to facilitate that integration is one thing, but the other side of the handshake is really there's a set of concerns that the consumer of the service is going to have. So there's a set of consumer management capabilities that are useful, right? You need to make sure that your consumers have a way of signing up and getting access to the services. You need a place for them to test out their integrations with the APIs. You need a place where they can potentially communicate with other consumers to share experiences. And obviously you need a place for people to find the services and APIs that you have available, and then documentation that tells them how to use it. There's a product management angle, which definitely factors in if you're offering APIs to the outside world where you have plans and pricing and so on. But even internally, if you've got some, customer information API that's going to be used in every division of the organization, that really needs to be a product. So you need to have product design thinking. You need to have a plan for a release management plan, a roadmap. You need to think about not only what data you're going to offer through the API, but what are the service level expectations and security policies associated with that, and defining those, as well as looking across the whole portfolio of APIs. So that's another bucket around product management. There's the development life cycle around, building APIs, designing the overall system from an architectural standpoint, then getting into the individual APIs, designing the interfaces, turning existing assets into APIs, having an IDE to develop in, virtualization technologies to decouple development efforts, and then, of course, deployment pipeline to push everything through. That's another bucket of capabilities. Runtime management, critical, like a platform that allows you to do traffic management and regulation of API calls, enforce access control and other security policies, enforce those SLA policies, the rate limits and so on, deal with exception handling recovery, as well as doing all the monitoring and metrics to ensure everything is running in a stable fashion. So I've just broken API management down into 4 buckets, but we have other integration capabilities as well. At a lower level, we may need to do aggregation and federation and virtualization. We might want to deal with bulk data, transformation and obfuscation of data, protocol translation. Like, those are all lower level things that might happen. And then we get into more of the task and process automation, where we might have specific industry use cases or proprietary connectivity to packaged software solutions. You might need more, no code, low code composition of services. But this is just a way of saying, instead of looking at everything and wondering, do I need to implement this product, or do I need to implement this new open source technology that's come out? If you first think about what capability are you looking for, that can really help give you a layer of abstraction to deal with the complexity, and then drill down deeper as you go. And as I said before, there's different ways of packaging these things. And I think it helps to kind of do some mapping here. Think about, how do we implement these things, right? So we've got, in the consumer management space, this is where developer portals are kind of in the industry standard. We have our community manager that I think takes it to another level in terms of having more of an interactive feel, and more of a developer relationship management feel to it. But there's whole product categories built up around consumer management. In terms of product management, there's there's lots of sort of whiteboarding tools and so on that go around just general product management. But this is also, we get views of this in an API manager that allows you to have an administrative view of your services. Design and development, it's pretty blurry line there between where the API development stops and the service development or microservice development begins. But you see whole categories of tooling around API design. There may be some API specific IDEs or other cloud-based IDEs that are used in development. And then, of course, with runtime management, we come to the crux of the issue, right? Is that the capabilities we listed in runtime management, let's go back for a second. Traffic management, access control, policy enforcement. That's kind of exactly what an API gateway does, and it's exactly what a service mesh does. And I'll talk more about the evolution of service mesh in a minute, but I think that helps clarify that, from a capability standpoint, these are not different things. It really comes down to the deployment environment that determines what, which option makes sense in which scenario. Now, in the data distribution, task and process automation, we see some, or maybe legacy integration tooling, which kind of still relevant there from a functionality standpoint. But again, it may be easier to kind of navigate through the capabilities and then determine what types of implementations are needed. Then you can take another pass looking at other dimensions of complexity that you're dealing with. So, even pushing further on this application network analogy, right? The fact is that in a big enough organization, it can be kind of difficult to control everything at the center, because you may have teams that are moving at different speeds, right? You might have different flavors of deployment. You might have a group over here that's doing Kubernetes. We can say that they're kind of a subnet on the application network. We might have an organization over here that, for good business reasons or just for interest areas, they've gone all event driven. Maybe they're event sourcing. There's a pocket doing that. And then you might have a group that's going all in on serverless, and so they have a different sort of paradigm they're working in. But the fact is, they're still all part of the organization, and there's still going to be places where you need to share that stuff. So, this is really, when it comes down to it, your view of the capabilities may change depending on where you sit. And there's going to be some capabilities that can be applied locally, but then there are others where you're going to want to apply them enterprise-wide, network-wide. So what are those network-wide capabilities, right? You want to be consistent in how you're provisioning access for consumers, especially when you're dealing with a common set of consumers in the organization, either internal or external. You want to have common tooling around their sandbox environments, around how they collaborate and so on. From a product management standpoint, your portfolio management really is the job of looking across the whole landscape of APIs and figuring out what to do with them. And then defining the policies around service levels and other security policies, something that happens network-wide. Runtime management, again, interoperability is fundamental in this overall application network. Like, if you want to reduce friction, you have to have interoperability. And there's a whole other separate talk track I have around the importance of focusing standards on interoperability rather than on just, standardizing everything. But traffic management, access control, you want to have a common way of communicating. So that's network-wide. And then from a design perspective, designing the overall system, that comes into consideration as well. But the reason I put this up here is because this is really the ethos of MuleSoft, where we see ourselves, right? We're not trying to be the technology that you're going to use to implement everything in your organization. But we do want to be the unified platform to provide that application network view, which means we need to be able to plug into all of those different subnetworks, right? The container team, we need to make sure that their services are available and viewable across the organization. Same with the event-based, same with the serverless based. Same with just the standard RESTful API groups and whatever technologies they're using. So, that's really the message. That's really the framing of where it comes. When it comes to service mesh, right? This is really about accepting that it's not like you'd say, throw out all of your old middleware and everything moves to service mesh, right? You're going to need those capabilities everywhere. In some places where there's real synergy with the way things are being deployed, like in that container-based group, then you may be using service mesh as the more sort of native form of interoperability and the place where those runtime management capabilities are implemented. But if that's the case, we want to make sure that when it comes to providing discoverability of those services, when it comes to providing consistent enforcement of access control policies, that you have the ability to do that and plug it into that service mesh group, as well as the API, RESTful API group, and the event group, and so on. But I will just kind of briefly on service mesh. I was actually, having been so immersed in the microservices world as it exploded in 2014, 2015, I was pretty plugged into the origins of service mesh. And, it did start with this, there was the Fowler-Lewis microservices post. If you're familiar with it, what they did is they described a set of characteristics that define microservices. Right? There are things like products, not projects, decentralized governance, all these different properties. The one that probably stuck in people's mind the most was smart endpoints and dumb pipes. So I can't see or hear anyone right now, but I would love to see in the chat box if anyone has really come across smart endpoints, dumb pipes. Incidentally, I co-host a podcast with another Mike Amundsen called APIs Unplugged. We literally this morning recorded a session where we drill down on that smart endpoints and dumb pipes, but I'll spare you that. The origin, so what happened is people got into microservices. So this is great. We like what this, what this is saying. We like where this is heading. Let's embrace the principles and go implement them. And I've seen all sorts of different flavors of extremity on how much you're going to go smart endpoints, dumb pipes. I worked with a company in the US who their enterprise architecture group went so hard on smart endpoints, dumb pipes. They were trying to get their application teams to embed network routing logic into every microservice they built. So I tried to walk them back from that, say, I think you're taking it a little too far. But what's interesting is, the whole smart endpoints, dumb pipes thing was a reaction to kind of this monolithic integration middleware story that had come up through the SOA days and ESBs and so on. Kind of the antithesis of the API-led approach. And so these microservice developers were saying, okay, we're going to build everything into the service, and it'll be standalone, resilient, and it will just interoperate with the other services. We don't need any middleware there because these are smart endpoints. The pipe is just the API calls or the event broker. Through that process, they realized that, hey, we keep building security in every service. We keep building routing in every service. We keep building monitoring in every service. Maybe there's a way to standardize these things. And Netflix went and open sourced their microservice libraries. People said, okay, shared libraries. Let's take those libraries and embed them into our code, and away we go. Then they found that by binding these libraries of functionality into every microservice became a change management nightmare, because if you wanted to make any change to the libraries, you had to go and basically unwind all the applications that were running. But then, Docker and containers exploded, and people realized that maybe there's another option here. Maybe there's a best of both worlds option where we can have the separation of concerns by having that shared functionality into a container, but we can co-locate it with the service in the sidecar model so that we get nice runtime optimization and more, it feels like it's part of the same service. So all this is evolving in this whole, and then coming out of that sidecar approach was, hey, service mesh. Here's another way of doing this. So, it kind of evolved in a vacuum from the middleware, but it's just funny that it sort of led back to the same place where, and in parallel, the integration middleware space had evolved from monolithic integration broker, what they were calling ESB, into more of an API-led approach, arrived in similar places. But I think there are some specific aspects of service mesh that are really tightly bound to the container ecosystem, the Kubernetes ecosystem. But the point is, they're doing the same things, and in a heterogeneous enterprise environment, if you embrace the heterogeneity and you recognize that you're going to have service mesh here, you're going to have service proxies in some places, you're going to have API gateways in others, you need a way of having a consistent control plane to see all the services and connect to those various endpoints. So that, just to sum up, the main points from my talk, we've got APIs and microservices, which are themselves really intended to help us deal with complexity, but they themselves have spawned these vast, complex landscapes, ecosystems. I think the application network idea is really helpful, and even when you stretch it to consider things like control plane versus data plane, networks and subnets, so on network segments, it can be very helpful. I think we can look at that control plane as being this set of technological capabilities first, and then look at the technologies that implement the capabilities as one layer below that. And I think looking at things through the capability lens is helpful. And just giving that example of how we can look at service mesh as being a new way of implementing these consistent capabilities. So at this point, I will, we're coming up to our first trivia question. So we got to state the rules because there's prizes on the line. So if you pay attention to any slide, this is the one. We're going to put up a question. We have the question first. Then we're going to show the answer options. I'm going to read through those, but don't answer until Jimmy types "go now" in the chat box. And he's going to do that after we read the final option to answer. So once you see that, then you can answer either A, B, C, or D in the chat section, but only give one answer, right? Like it would be very clever to go in and just type A, B, C, D and get your prize. You'll be disqualified, right? Make sure one answer only per participant. So we're going to have a couple questions now, and then we'll have a little Q&A. So first trivia question. In which API management capability category, those are the 6 blue boxes, would you classify API documentation? So API documentation is a capability. Which category does it belong to? Again, wait until I've read all 4 options, and then look for Jimmy to type "go now." All right. A, is it part of API design and development? Part of B, API consumer management? C, API product management? Or D, API runtime management? Right. And I'm flying blind, so I'm going to assume the "go now" has happened. Maybe Jimmy, if you just want to verbally.
Yeah, it's working. So yeah, got it. Go ahead, man. We got a winner.
Right. Are the answers in?
Yeah, we're gonna announce the winner towards the end. So yeah, thank you for that. Yeah.
Okay. All right. We can now go on to question number 2. All right. Which of the following capability implementations, so remember the second slide I showed with the 6 boxes where we had different components, is classified under API runtime management? So I'm going to list out some implementation components, and you have to say which one of these belongs to runtime management. All right, here are the options. And again, wait for Jimmy to say "go now." Don't answer yet. A, API gateway. B, API developer portal. C, RPA, robotic process automation. Or D, ETL.
People are so fast.
They're probably using some RPA to
Yeah.
do automatic recognition, chat response. Cool.
We have a winner here. Go ahead, Matt.
Okay. All right. Great. So thanks for the engagement. Super accelerated engagement. So here we're going to pause for Q&A. Now, maybe there have been questions hitting the chat already, but we'll go back to the first 4 questions that Mandy listed out. I'll start. I want to answer the first one because I think it's the one that probably didn't get covered in as much detail because it wasn't totally, aligned with the storyline. So I'll answer that, and then maybe we'll Jimmy, if you want to read anything that's come up in the chat. But so how granular should microservices be? And this is like, how long is a piece of string type of a question. As I said before, I'll just give some general experiences in consulting with companies in the microservices. There's a few rules of thumb that are related to this. Number one, there is a relationship between size of the team and the size of the microservice, right? So, if you fully embrace microservices in the Fowler-Lewis sense, how it was defined with all those characteristics, then really the goal of that whole architecture was to decouple development efforts. I mean, if you go, long before the term microservices was around, Werner Vogel's CTO of Amazon Web Services, he did an interview with the ACMQ publication talking about describing Amazon's architecture, and it very much was along those lines of you build it, you run it, teams are working as independently as possible. You've got, and I've seen this model actually in a lot of places that would be kind of self-identify as microservices shops. So you've got these independent product teams, cross-functional, talking directly to customers, working all the way through to supporting their products in production. And then you've got platform teams who are really building tools and providing platforms to those teams in an enablement capacity. There's really a relationship to, how many services can that team handle, and that kind of defines how big services are. But the thing is, microservices, like every term in tech, is overloaded, and sometimes people are just talking about an actual runtime component that could be either a standalone application component, or it could be some facade on top of another application, providing sort of API enablement. So, you have to really nail the context. I think, though, that maybe the most practical rule of thumb would be, I find it's better when you're decomposing services, it's better to start bigger than smaller. Like, the goal of microservices is not to break things down to their atomic particles, right? To their atoms. It's really to, like I said, decouple development efforts, provide reusable functionality across the organization or outside. So if you're consumer driven about that, consumers are going to want things to be bundled to the level of granularity that's most useful for them, right? If I'm a mobile app developer, it's better for me to make one call and get all the information back than to have to make 15 calls, right? And then, in a totally parallel topic, that's kind of the popular GraphQL use case. But to solve it in a microservice architecture context, it's better to break things down into bigger chunks and then maybe break those down, because it's easier to break something apart than it is to glue things back together. So I hope those are a couple of practical rules of thumbs related to that, but there is no, it's not like, the answer is 42. It's just there's a lot that goes into the decisions there. So I'll pause after that answer, and then Jimmy, are there any questions in the chat that came up?
We have a couple of questions. I'll let Mandy go through those questions. Mandy, go ahead.
Sure.
And Matt, so the first question we have for Matt is, can we marry microservices and graph data queries?
Great, perfect. See, they're a perfect segue because You know, I think that if we're talking about GraphQL, right, then you know, GraphQL itself is something that can be deconstructed, because you know, as from a if you look at the problem to be solved, it's one solution to the problem. So the problem that GraphQL you see most popular is the one that I just described. I'm a front end developer and I don't want to make 15 REST calls because I want to just get everything bundled in one response. So, and the other thing it does is say, we're going to put the actual bundling in the hands of the consumer. So it's up to the consumer to decide that you're going to figure out what message format you want to send. We'll give you a schema and you construct the message, right? The third thing I think is around type safety, but that's a totally separate topic. But you know, and this kind of arose, again, context is important. GraphQL came out of Facebook, but I think more generally it's taken off in the JavaScript community, particularly, you know, certain framework developers, React and so on. And in those worlds, I think the blind spot is there's a lot of development where the front end developer is also the back end developer or their neighbors, right? There's a very good close proximity between them. I think the danger of the GraphQL approach could be that, you know, if it's not done in that sort of both sides of the coin context, then queries could become very unpredictable, right? Schemas can become very large, and then your monolith becomes the schema, and you don't have very good certainty around you know what types of queries you're going to get, and from a change management perspective, things become more brittle. So I think there are some risks there of just looking at GraphQL as a panacea, but I think they can work together, and especially in sort of controlled settings. So like I think if the schema boundary is really, you know, within the microservice boundary, then that's fairly safe. But also if you have boundaries around your consumer audience, then I think it's safe as well. And I think there's even ways of constraining GraphQL further, maybe not through the spec, but through other conventions of, you know, here's how you should build APIs through GraphQL. There's ways to protect against those risks. But the other side of it would be the reason, like the problem statement around what make GraphQL so popular is that I have to make these 15 REST calls. Well, that actually is a byproduct of the conventions of how people have gone out to implement RESTful APIs. They've been religious about one call per resource, right? There's actually ways of constructing RESTful queries that aggregate things, right? I mean, we've proven that many times. Our whole layered architecture kind of promotes that. So, you know, I think that this, even in the microservices community, they have this notion of backends for front ends, which is very much similar to our experience API concept, where you would have a kind of a single gateway or access point that's for a particular front end. You know, that's an optimization place where you could do the type of aggregated queries. So yeah, they can definitely coexist. I mean, microservices can coexist with non-microservices. In fact, pretty much do everywhere where there are microservices, because I don't think there's not a single place where everything is microservices. So I hope I answered the question there.
You gave a really for that. The second question is,
Oh,
Your voice is cutting, Mandy. Yeah, we lost audio. I think I can ask the second question.
Sure.
Is asynchronous a necessary attribute for microservices?
Is asynchronous necessary? Definitely not. I mean, even going back to the origins of the definition, the Fowler-Lewis definition, right? They within that smart endpoints dumb pipe section, they called out, hey, the way we're seeing people implement this new pattern is through RESTful APIs and lightweight event bus. So they were calling out synchronous and asynchronous right there. I actually have a blog post I did at the start of the year where, again, taking this idea of abstraction, say, let's forget about Kafka and HTTP and GraphQL and all that, and let's think about what are the actual interaction patterns in any sort of integration scenario. And I see the world as there's three types of interactions. There's queries, so interactions where information is queried, but there's no state change. It's just, letting the consumer know information that the provider has. There's commands, which are one party asking another to do something and waiting until it's done, right? Or not, or assuming it's done. So state changing action. And then there's events, which are more when something happens, communicating that out to whoever pays attention to it. Even in those three patterns, I think that's a different way of just sync and async. Those can each be modeled at runtime over synchronous protocols or asynchronous protocols. The bottom line is you're always going to have these different patterns of interaction. So there is no pure event-based architecture. I think there's always, at least at that semantic level, you're always going to have queries, commands, and events.
Cool. Thank you, Matt.
And I think we covered how service mesh different from API gateways. I'll just one more note on that I think that there's this convention out there to say, well, API gateways can be for north-south traffic, and again, in telco terms, that's like outside traffic to the inside may go through API gateways, and service mesh traffic is for between services, east-west traffic. That's can be a bit of a rule of thumb, but then again, if you're in like this full-blown Kubernetes infrastructure, you may have some ingress gateway role for your service mesh. So it does depend. But I think the idea of thinking through, even just knowing what are your north-south interactions versus your east-west interactions, allows you to make good choices on how you would solve it. And they can be used together. I described that. Security, I just have a feeling that security is a topic for another day. It's because it's such a deep topic.
It is, yeah.
But it's definitely, should always be a central consideration from the outset. And I think, again, thinking through the patterns of interactions, east-south, east-west, north-south, helps to come up with a security model. My answer there is, go read the book. I think you can get free copies on the web with it, the API book. Cool. But at this point, so I'll stop presenting now.
We have a couple of more questions, Matt.
Okay.
Mandy, do we have you back? Do you want me to read the questions? Oh, we still cannot hear you. Oh, sorry about that. All right, so Matt, what is the role of data normalization in microservices? And are there any consideration to what extent we need to normalize data to be able to reuse?
That's a great question. So I think, I would say one of the things that's become really popular with the explosion of popularity of microservices is domain-driven design has come back in a big way, right? And if you look at domain-driven design, first of all, I think that one of the big reasons it's so popular is it kind of is if you look at context mapping and domain-driven design, that's kind of the way you draw that application network data plane view I was talking about. Here's your domains and subdomains and bounded contexts and the functions that are in there. So that's very helpful because you're ignoring the technology implementation details and focusing on business complexity. When you go a layer beneath that in domain-driven design, it does become kind of very object-centric, data-centric. I think that one of the lessons we've learned in the last 20 years is definitely trying to come up with a canonical data model for a large enterprise is a bottomless pit. And that's why the idea of bounded context and having, chunking things up and having, models for your domains is a more practical way of going about it. But, there is definitely a data aspect to microservices. And I think this is where some of the microservices purism breaks down a little bit, because data, software functionality is stateless and can be moved around everywhere, but data is persistent and it's just harder to move, harder to segment, harder to abstract. So, I think one thing that will be, I think another, I keep deflecting answers and going to rules of thumb, but I think a helpful rule of thumb here is something that comes from Mike Amundsen, who's written many books on APIs and microservices, and he talks about your data model is not your object model, is not your interface model, right? So when you shouldn't, like, it's helpful to have a good, strong understanding of your internal data model for a microservice, but don't just regurgitate that as the interface model. It's actually better to be consumer driven on what you expose, and you kind of follow Postel's law and say, be liberal in what you accept and conservative in what you send. I think that's how it goes. But the idea would be, just have the information that the consumer needs. Because if you just, and I think this is where we're going to see over the next few years, all the blogs about, GraphQL is the greatest thing that was ever invented in the history of the world will become, oh, GraphQL is giving me all this pain. I think one of the pain points is going to be around just consumers binding the entire data model into the whole schema into their consumer side is going to cause some change management problems. So if you're more thin and focused on what consumers need with your interface, then you can loosely couple that back to your internal data model. But yes, I think the data considerations of our microservices are some of the more challenging.
Thanks, man. Thanks, man, for the great overview. Thanks for answering all the questions. There was one last question asking about the podcast you had. So it would be great if we can.
Now that I'm not in sharing mode, I'll drop the.
Yeah, drop the link in the chat. Thank you very much.
Great.
I think we'll switch over. Thanks, man. I think we'll switch over to Ganesh. Ganesh, go ahead.
All right, perfect. Thank you so much. So that's a tough act to follow with Matt. And Matt's talk, you've given us a lot of food for thought and a lot of information, Matt. Thanks for that about microservices and stuff. Now we're going to focus on Anypoint Service Mesh. So we'll take a little bit of a pivot and move from strategy and what microservices is to how MuleSoft is tackling the whole concept around microservices. I'm just going to share my screen. And let me first present, just open this up. And I want to make sure that we're on the right slide. Granular Anypoint Service Mesh. Okay. So share screen. Tab. Let me know if you can see my screen and if you can see it properly as a full screen.
We see the presenter.
You see the presenter view?
Yeah, switch over to the other.
Yeah, I'll just switch over to the other view. Yeah, that's why I wanted to confirm. Do you see it now?
Yep.
Okay, and it's fine, right?
Perfect. Yes, go ahead.
All right, so we're talking about the Anypoint Service Mesh, and I'll just, over the next half an hour, 40 minutes or so, I'll walk you through slides. And obviously, I want to explain the concept, but I also want to show you how the product looks like, and I have a short demo. It's something that will help illustrate the concept. Okay. So what is Anypoint Service Mesh, right? We built Anypoint Service Mesh to help with the discovery of services and to be able to centrally manage and scale your application. So it's a MuleSoft solution that provides discoverability, management, and security for non-MuleSoft services deployed to Kubernetes. And you can do all of that from within the Anypoint platform. Now, to provide this, we work with the customer's instance of Istio. As you know, Istio is a leading open source service mesh technology deployed on their Kubernetes cluster. But what we do is the Anypoint Service Mesh has a concept of an adapter, a mixer that sits inside the Kubernetes cluster and acts as that translator between the non-MuleSoft services and the Anypoint platform. Okay, so now we had the reason we came up with this was we had a lot of situations where we had customers saying, listen, we have an existing .NET infrastructure, right? And we want to make sure that we repurpose some of those skills. We don't want to rewrite all of the code because there's tons of code that's in other languages. Can we use MuleSoft to do that? And that was kind of the genesis of the MuleSoft Anypoint Service Mesh. So what can you do? You can discover and leverage the service in any architecture. You can visualize the dependencies through the application network graph. You can maximize the adoption and reuse by adding it into Exchange. You can manage it centrally. So all of the API management aspects, optimizing the performance with the analytics, all of that is done through the MuleSoft platform. And then at the end of the day, security is something that is enabled by default. And Matt did talk about it. So we want to ensure zero trust with Istio and Envoy authentication authorization. So there's two layers of security. There's the Istio layer as well as the additional layers that you get with the API management that come with Anypoint Service Mesh. Okay, so let's specifically go over how this works. As you can see on the top, you have the Anypoint platform, and that's got all of the API management capabilities. Yeah, it's got the microservices built with Mule. These mules could be deployed within Cloud Hub or a runtime fabric or on the customer's premises. Now, when we introduce non-MuleSoft microservices built into the Anypoint platform, that's what you see on the bottom right. And we work with customers. So again, Kubernetes is a mandate. We work with the customer's Kubernetes cluster and their own version of Istio to do that. And as I was saying, so this kind of gives you a view of how non-Mule applications and Mule applications can coexist and be managed by a central sort of a management plane. Okay. Now, when you do this, one of the biggest what are some of the benefits, right, of an application network? You're going to empower your customer to build according to their strengths, as I was saying, .NET, Java, whatever the case may be. Right, it's going to make things pretty consistent in terms of how you manage your APIs, right? And you're also going to maintain that flexibility, right? If for example, it bends, it does not break. It's built for change, right? It makes it really flexible for you to start changing your on-prem apps, or if you want to flip it and replace it with a Mule app, the management plane is the same, and that's what's really different about it. Now, we're going to look at a few aspects around this. So, for example, well, I'm going to walk through a workflow of sorts, right? And this kind of shows you how some of our customers have used the platform to do this kind of stuff, right? So today you have services deployed in the Anypoint platform. You have services deployed out. Dev teams are contributing to both. So you potentially have an inconsistent governance across the tools, right? So a lot of my customers are currently deploying applications on Azure, on AWS, on GCP, OpenShift, and a few of the other aspects as well, and platforms. And they have a bunch of other skills. So, as an example, one of the organizations that I was working with came came to me with a challenge saying, "Listen, we have three platforms. Um, we have IBM, we have SAP, we have IBM Data Power, and we have Azure for API management. And anytime I need to create an API that needs to be exposed, this I have to build in four different places. Security has to be built in four different places, management in four different places. And that's really slowing down the way we work, the slowing down the way we can respond to the business. That was one of the biggest reasons for us to start really thinking about service mesh as as a potential solution to the problem, whereby we'll take away all of the governance and management requirements that you have in the middle two layers and kind of replace it and consolidate it into one specific layer that's built on the Anypoint platform. So let's take an example. Here's a Kubernetes cluster. Okay, K8 is a polyglot environment. It does not force you to build applications in any one language. So I'm going to build these slides out. And at the end of the day, when you create your applications in Java, Ruby, and Python, you're actually putting them in Docker containers and Kubernetes clusters. Docker and Kubernetes are great when you think about you want to manage the physical deployment of services, but they really don't address things like communications and security between services that well. So if service A calls service B, the developers have to, kind of manually put in things like TLS, MTLS, and authentication. This is the east-west traffic. There is the concept of sidecars, yes, but still, the east-west traffic is something that's implemented to be very specific to one service talking to the other within the same cluster, right? And the sidecars manage and standardize inter-service communication security. But with or without a service mesh, multiple clusters can become silos. So that imagine this is one K8s cluster, but then I have organizations that have multiple K8s clusters based on different lines of business, and they want to keep that separate. Now, the moment you go into multiple clusters, there goes your centralized monitoring and management, and you have individual Istio, dashboards that you're going to have to look at. Even if so when you think about this whole service mesh concept, even with Istio installed, you're lacking API management, you're lacking analytics, and more importantly, you're lacking a catalog. Okay. Now, with Anypoint Service Mesh, what we do is we enable connecting the Kubernetes-based microservices to the Anypoint platform. So Istio is there. We deploy the MuleSoft adapter, which has two jobs. There is a check job and a report job. Okay. The check is to see if there's any policies that need to be pulled down from the Anypoint management plane to the sidecar, which is kind of managing that specific API or microservice. And the second is the report, where the MuleSoft adapter goes up to the management plane and reports things like, the failed request, successful request, the time it took to do the request and all that stuff. So processing times, all of the specific metrics, the wireline metrics that you're going to be interested in, that is something the MuleSoft adapter does, right? So the whole concept is dropping the adapter in there, and how do you bind it to those specific services? There's obviously steps for us to do that. Now, because we have the adapter in there, and now we have the concept of running what we call ASMCTL, which is Anypoint Service Mesh Control Utility, that you have the ability to bind your existing services to Anypoint assets, and it kind of registers itself as an asset inside Anypoint Exchange. So existing microservice got the MuleSoft adapter on top the commands as part of a script or a CI/CD pipeline. It's going to take that microservice, it's going to configure the sidecar, and it's going to go up and register itself with with the MuleSoft Anypoint platform, where it says, okay, here's my asset, here's my API ID. You remember there's this the concept of having that auto discovery, so that auto discovery ID goes in there, and it registers itself inside the Exchange catalog. Okay, many different steps happen when this happens, but at no point do you have to go in and change anything, any code that belongs to your microservice. Okay. So now what you can do with this particular, when I have a picture like this, is you can manage and secure services from one place, right? Anypoint's service mesh is not a service mesh in the true sense of the word. It works with a service mesh. It's a service mesh enablement capability for the Anypoint platform. I would probably describe it as Anypoint for service mesh, as it brings Anypoint capabilities to a service mesh environment. Now, we do this by automatically discovering services, as we spoke about, creating proxies, which are visible in the API manager. I'll show you that, right? Visible in Exchange, visible in Anypoint monitoring, right? These proxies are a little different instead of what we are used to. So in the traditional sense of the word, when you build a proxy in the Anypoint platform, you have the option of creating a completely separate and isolated microservice that is disconnected or decoupled from the actual API, and all it does is the gateway functionality and the proxy, right? And they live within MuleSoft. In this case, the proxies live within the MuleSoft adapter inside Istio. You can think of the adapter as, I would say, a super proxy. So like for that specific cluster, you have one adapter which is going to be managing the process communications for all of the specific components and APIs deployed. So which means there's no explicit Mule runtime required to run the proxies within Anypoint Service Mesh. Requests coming in do not go to MuleSoft. They go directly to the Kubernetes cluster. They are intercepted by the adapter, which talks to MuleSoft and comes back and does its stuff. Okay. How does this work? I'll just walk you through. I mean, this is a diagram that I think is going to be really, really interesting, and it's going to be beneficial for you to start thinking about service mesh and how it works. So step one, here there's a client that could be another microservice or a Kubernetes ingress component. It requests service. Envoy is that component that sits inside the Kubernetes cluster that captures the request and it redirects it to the MuleSoft adapter through something called an Envoy filter. Now, these are all concepts that we will all need to brush up on and see what these are. But this is integral to the way service mesh works. The adapter is then going to perform some policy checks. As I said, it's going to check to see if there's any policy violations. And when there are no policy violations, only then it's going to route the request to the microservice. Now, the microservice runs the service logic in step 3 and sends the request back to the client. Okay, and that's it. Step 4 is essentially broken into two parts where periodically the adapter communicates with the Anypoint platform asynchronously to get the latest policies and contracts. Hence, when you apply a policy up in the Anypoint management plane, it may be a few seconds before that policy is reflected on within your microservice that's running inside your service mesh, right? But nothing runs up there. It's all running inside the K8s cluster. Anypoint is simply providing a very, very thin and lightweight management interface on top, or the protocol interface, and with that, it ties everything into the Anypoint ecosystem. And then, of course, asynchronously, periodically, the adapter that's sitting inside the Kubernetes cluster also returns API analytics information to the Anypoint platform. Okay. So what does this do essentially? If I were to summarize this in a little bit, we want to expose microservices in Anypoint. We want to support the auto creation from a Kubernetes command, or for a design first approach, right? We want to apply mule policies from API Manager. We can also apply Istio policies. You don't have to, it's not an either or. You can apply Istio's policies like circuit breaker and A/B testing from the Istio control plane, right? You can manage and monitor the service health, and of course the discovery and of exchange of the assets and the way you'll publish it to exchange. So this is kind of a summary, if I may, of some of the capabilities. Now let's take a quick look at a high-level view of the deployment architecture itself. If I were to look at the deployment architecture, right, this is a pretty detailed diagram. I'm not going to go and rip this apart. I think we'll obviously be sharing these slides with you, but you are also more than welcome to go to the Anypoint documentation website at docs.mulesoft.com, which has got a lot of this in quite a bit of detail, right? But even though this seems a little complex, let's take a look at the two main functions. That's API management and service mesh, right? So API gateways in this case act more like micro edge gateways. Now, one of the biggest things around this is with the advent of edge computing. Think about having a Kubernetes cluster or a Kubernetes deployment sitting on transmission or communication towers. Okay, that's edge computing. It's where when someone uses a mobile device to request a specific functionality or an app, there is a service that's sitting on the edge that's able to provide that capability. It doesn't have to go all the way to the end and get processed. Those are some of the applicabilities of having a distributed service mesh and having a lightweight service mesh like this, right? The Istio control panel obviously is something you can use to manage the containers that are sitting within the service mesh, but then there are certain policies that MuleSoft applies here. For example, at this point, there's client ID enforcement, JSON Web Token, rate limiting with SLA, rate limiting, OIDC, LDAP, basic auth, and periodically we keep adding policies that are applicable and that can be used through the service mesh as well. This is pretty much, you could almost think of this as a first cut or the phase 1 of our service mesh offering. So there's a subset of policies that we offer, right? And then here's the thing, because it is so seamless, it'll seamlessly fit as another deployment option alongside Cloud Hub and Runtime Fabric. So if you belong to an organization that has a polyglot development environment, you'll see the power of using service mesh and then standardizing all of your API management on one single platform. Okay. So what I'm going to do is I'm going to run through a quick demo here. And again, this is just showing you some of the components of the service mesh and how the components actually look. And once we do that, we'll move on to some of the questions that you may have, and then of course there's a trivia question as before, where we're gonna walk through that as well. Okay, so I'm just gonna stop sharing for a quick instant while I share the entire browser that I have, so you can see all the tabs. All right. All right. So please let me know if you can see my screen.
You can.
Okay. So, so for the purposes of this demo, I'm using EKS, okay, Amazon's Kubernetes service, right? And I've set up an EKS cluster. In this case, I've just picked North California. Obviously, it's Amazon. You can deploy whatever you want. But this is where I have certain, I have the EKS cluster. I got certain Kubernetes services and proxies. But as you can see, when you install the MuleSoft Anypoint Service Mesh and the MuleSoft adapter in here, it installs things like it installs this thing called a service mesh, okay. And within the service mesh namespace is a bunch of services that are deployed within these pods. So there's a webhook for listening for updates from the Anypoint management plane. There's a catalog manager. There's Envoy filter. You don't really need to know all of these. These are automatically deployed by the MuleSoft. I'm just showing you the guts of the application of service mesh itself, right? And considering we are all technical people on the phone, I thought you'll find this interesting. So a bunch of pods here. So if I click on this particular, the service mesh in cluster broker, for example. So here it's got it's got this certain containers that it's running inside, right? And here this is that specific pod, and this just gives you some information around what some of the configurations are for this specific functionality. Okay, for that particular pod, the service mesh pod. Now within the same pod, I've also have something called Mythical Payments, a namespace, which has got a bunch of business apps, right? Some of these apps are in Ruby. Some of these apps are in Python, right? Some of these apps are in Java. And so you can see there's a customer app that's responsible for getting customer information. There's the inventory app. There's the order app where you kind of set orders. There's a payment app, and then there's a user interface as well, which is like a simple web page that kind of mimics the concept of adding things to a cart. And I'll walk you through that demo as well. And then you'll be, it's calling these APIs and services that are deployed here. So like the customer app, for example, has got it's got a customer app. It's also registered inside an Istio proxy for it to have that connectivity from the outside world coming in. Okay, and this deployment, I can I think it's either Node.js or Ruby. I don't quite remember it, but it's behind the scenes. It was part of the installation script when I went through it. Vanilla Kubernetes type deployment, and then of course there is the Istio system. You have the Istio Ingress Gateway and the Istio daemon. That this is responsible for maintaining the whole sidecar and the adapter concept. This is what provides the guts of the entire fabric when you look at it. Okay. Now, when I install this inside the Kubernetes cluster through various commands, kubectl and whatever else you have, I was able to also use the Anypoint Service Mesh controller program ASMCTL to actually go and register these APIs, discover them, and register them through to the MuleSoft Anypoint Exchange. So I'm just going to take you to the Anypoint platform. Well, and this obviously looks familiar to you, so I'm just going to click on discover and share. Let me just log in here quickly. And here you can see that, and I'm just going to find that the ASM payments API, customer API, inventory API, and order API. So this automatically registered with the Anypoint Exchange. And then I would have the ability to go in and edit and say, hey, this is, for example, I could say this is the ASM external mesh customer API. Okay. And then obviously, this kind of reflects in, how this works. So we have an API, and this API is an external API. And because we ran those commands and we registered it, it also automatically went and it created API proxies for these APIs. Okay. So now the customer API that's actually being represented, let me go back to AKS. The customer API that's being represented with this customer app, right? This is visible and captured as a customer API v1 within API Manager. And that all happens behind the scenes, right? And just like any other API proxy, I do have the ability to click on it. I can go in, I can see what kind of an endpoint it is. It is an external endpoint, and I do have the ability to go in and apply policies to it, right? At this point, I've applied something called a rate limiting policy. Okay, and what is the rate limiting policy? Just for testing purposes, I have one request in a minute. It's not going to allow me to add more than one request a minute. And this is when you're actually getting back customer information when you're starting the checkout process, where it validates who the customer is. Okay, so let's go to, and here's a policy, and then what we'll do is we'll also keep an eye on some of the monitoring aspects, right? So now if I go here, this is the mythical retail. This is the actual user interface that runs of that service mesh UI app that is registered within EKS. So this UI, when this is the app that powers this specific interface. Okay. So what I'm going to do is I'm going to click on this mule ears, add to cart, right? I'm going to check out, right? And here's my email. I'm going to continue, and I'm going to say authorize payment, place order, and it's done. Okay, so now it's done. It sent an email out to M. Ruiz. Now remember, we have a policy in place. Now the same user comes in, tries to add, maybe the same thing, tries to do a checkout, and does a continue. In this case, the continue doesn't work because that policy violation kicked in. I'm trying to call the customer API again in that specific threshold before the threshold has expired. Okay. So if I go back to the MuleSoft Anypoint platform, and I could potentially show you the logs for the EKS containers as well through kubectl. But if I go back here and we can see, go back to API administration, v1, and I'm also actually going to go into the monitoring page. Let me go to the monitoring page, and we'll be able to see these external APIs and apps from within the Anypoint monitoring view. Okay, so I'm just going to say, so within the last, let's say within the last 3 hours, confirm. So I have been testing. It did get some requests. When you see this, when I was working over the last couple of hours, and I was, kind of creating some test data for testing this app out, I actually ran through 15 violations of that specific API. I kept clicking, click, 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 right? So and it kept failing. But the reason why this is being populated is that the MuleSoft adapter that's sitting inside the Kubernetes cluster is sending those policy violations up to the cloud, and it reflects in your analytics page. I didn't have to do anything special. I just had to make sure that those APIs were found, they were configured, and they were cataloged through ASMCTL commands. Okay. Going forward, we've also introduced concepts such as connected apps, whereby there's more of an automatic generation. It creates the API shell first, and then you can associate that with the service mesh, components you have today. There's different ways to do that, but the whole idea is to simplify your deployments and to simplify the management of your applications. Okay. We'll obviously take questions on this. So this was pretty much a short demo that I wanted to showcase in terms of showing you this Anypoint service mesh in action. Okay. So if I were to go back, I'm just going to stop sharing and I'll share my presentation again, and we'll just go back here. So APIs and microservices. Okay. So can you see my screen? Okay. So what are the key takeaways here? Service mesh helps to make your service to service communications fast. It's going to make it more reliable, more standard. When you start deploying microservices at scale, somebody had a question: how granular should you go? I mean, there are times when organizations and business units and project teams tend to go really granular because it's pure placing. Everything has to be a microservice, right? And then you kind of find that at the end of the day, you have so many microservices that managing them becomes a problem, and that kind of you're not able to scale. So I don't see it either or. I see service mesh and API management as complementary functionalities. You think about service mesh as a container to deploy and manage and standardize the deployment of applications. I see API management as the standardization of the governance layer, right? And they can be used together to manage services at scale. So, trivia question. As said before, so I'm going to ask you a question. It's going to have one answer. It's got an A, B, C, or a D. And please wait for Jimmy to type "go now" with an exclamation mark. Once you see that, you can start responding. So, which statement is not true about Anypoint service mesh? You can expose non-mule microservices as APIs in Anypoint. B, you can apply mule policies from API Manager. C, you can visualize microservice dependencies using the application network graph. D, Anypoint service mesh comes with its own Kubernetes cluster with Istio pre-configured for simplifying deployment. Right? And we're going to wait for Jimmy to say go now and go.
Got it. Thank you, Ganesh.
Okay.
We got opener here. Go ahead.
Okay.
Okay.
All right. Perfect. So I think we should go to questions now at this point in time, Jimmy. And I like to take these questions and kind of talk to them. And Matt, please feel free to chime in as well. I could do with any of the points that you have in mind as well. A good use case for Anypoint service mesh. I was telling you, company A that I'm working with has services deployed in .NET. They're using Azure for a lot of things. They also have a bunch of IBM specific services deployed in Java, and they want to be able to manage that from one specific plane. So they don't want to use data power and Azure and something else, right? It's got to be the one. That's where MuleSoft Anypoint Service Mesh comes in, and it's a great fit for them to standardize on Anypoint. The other thing is you may have, let's say when you have a truly polyglot environment and you already an existing MuleSoft customer, right? A lot of our service mesh customers are existing customers. They don't buy MuleSoft because they need to deploy a service mesh. They have MuleSoft, but they want to extend the power of MuleSoft to other areas in the organization. That's where service mesh comes in. In terms of best practices for Anypoint service mesh, we do have documentation on that, and I wouldn't go through all of those, but having those specific namespaces, defining the namespaces, then the nomenclature, the naming conventions for the namespaces becomes important. We do have best practices for sizing out the mixer, because when you think about it, there's one mule mixer or adapter that's going to be sitting on top of all of the other services, right? Now, you don't want to overwhelm that fellow. You want to make sure that that mixer has the capacity to service all of the requests that are coming. So you want to make sure that it has the resources, the cores, and the memory that is required. So those are some best practices. We're going to help you size out the size of your MuleSoft mixer. Okay. And in terms of the third concept is how flexible is the deployment. It's Kubernetes. I mean, that it doesn't get any more flexible than that, right? So you have K8s, everything is a container. There's nothing that you have to do explicitly to provision the infrastructure for, whether it's a database or an API or a flow or an event, a queue listener, or whatever the case may be. That's one of the biggest things about Anypoint Service Mesh is the flexibility, right? Where we don't force you to build stuff in MuleSoft. It can be non-Mule, and it still works within the MuleSoft ecosystem. Okay. So that was pretty much it And I'm gonna stop, and I'm gonna give control to you, Jimmy, because I think the next we are getting into the trivia
Uh,
section.
keep the control with you, Ganesh. I'll just go through the questions that we got through the chat here very quick. So the first question is about it's saying why we should not use Istio by itself without the MuleSoft.
Yeah, so great question, right? Again, Istio does a lot of things. It's got those policies, it's got its control plane. What Istio does not do well is the cataloging aspect and having that north-south security. The north-south policies are something that Istio was not built for. It was not built for it. It was built for intra-process communication within the same cluster, right? And then take that to the next level where I have multiple clusters and multiple namespaces. Right now, each one is going to have its own version of Istio and its own governance, utilities, its own flavor. So how does that centralize stuff? So you're just adding to technical debt and you're making your deployment more complex than it needs to be. That's where MuleSoft comes in and complements Istio.
Perfect, thank you. What is the difference between using MuleSoft application as a proxy versus as a proxy to other APIs and services versus implementing service mesh?
Could you repeat the question again, Jim?
So the question is about for other services, why we don't just build a MuleSoft proxy on the top of the other services, why we would go to the service mesh.
So I'll tell you the biggest reason for that is co-location policy management. So when you build a MuleSoft proxy, the MuleSoft proxy is going to reside, inside a MuleSoft environment. So whether it's runtime fabric, whether it's in the Cloud Hub, that adds some level of complexity in terms of the networking that needs to happen, right? So for example, now instead of going directly to your cluster, a user or a mobile app has to connect to the MuleSoft proxy first and then get redirected to your cluster, right? So that is an extra hop. When you want to optimize, you would definitely prefer to have that all co-located within the cluster.
Okay, cool. That's a nice one. And also, one of the questions that we typically get from our customers, it's not in the chat, but this is just, we typically get this if we can touch on Ganesh, about performance. What is the performance overhead that the MuleSoft adapter would add to the service mesh or the services deployed within a cover within the cluster?
Negligible, right? Because it's all co-located inside the cluster. It does not go out every time the request comes in a synchronous manner, right? It has gone and pre-fetched the policies. It's installed the policies there, and all the policy checks happens within the pod inside your Kubernetes cluster. It does not go out. Only analytics is sent out and periodic checks for policy updates that get sent out.
Another question about the adapter: does it sniff all the HTTP requests and responses in and out of the cluster? If so, what if we don't use HTTP inside our Kubernetes cluster? Instead, we have some sort of event-based triggers using queues and such.
That is a good question. I mean, if you have queues, would queues be something that we could manage with a proxy? I think evented queues is something that's on the roadmap, or evented APIs. I would think this would be more in terms of the evented API conversation, Matt. What do you think?
Yeah, I think so. I mean, I think the idea, and see, you used polyglot. I forgot that's the I was saying heterogeneous. I'm dating myself, right? But yeah. I mean, I think the fact is that we are in the diverse landscape, and so when it comes to asynchronous communication, I think that there's probably a threshold at which you can use one tool to do all the different use cases. But if you start to get into some more, high scale asynchronous needs, then we have options there, right? We've got.
And I think typically with event-based architecture, it's usually the governance and security are usually delegated to the broker itself. Like you wouldn't need to have some control because everything is delegated to the broker. That's, I guess, what I think. So can we say here, like, kind of service mesh is mostly for HTTP request and response? That's basically the common use case.
Yeah, I would say that at least in the way we are managing it, because when you put that API, lens, and when you look at things from an API lens, and obviously HTTPS becomes the language that the web speaks, right, and that the mobile apps, etc., speak as well. Yeah.
Okay.
Yeah, and I would think, just to add to that, I do think it's a bit of an industry gap around those capabilities as described for for synchronous communication and HTTP where it's very, very mature, versus the asynchronous world where it's been very proprietary. So yes, you can get some functions like that some of them in an event bus, an event broker, but that sort of holistic policy management and covering all the things like traffic management universally, like we've seen the async API spec now become popular. I think the idea of more general plugging that into the application network tooling is coming. So, just applying the safe harbor statement, more to come on that later, right? We have definitely some ideas and solutions.
Okay. Another question: what is the benefit of MuleSoft Service Mesh versus OpenShift Service Mesh? I guess you touched on this already, Ganesh, when you used one.
It's a different product. I don't know much about OpenShift, so I'm probably not in a position to answer that question. But like I said, if you're in the MuleSoft world and you are an existing user of MuleSoft, you've seen the benefits and the power. It doesn't matter if you're using OpenShift to do something else. By all means, go ahead and do that. But wouldn't it make sense to standardize your API management? And your non-Mule application management under Mule, and that's about it, right? So it's almost like here's this is a 6 for you, but when I see it like this, it's a 9 for me, right? So yeah.
I mean, I think it's like OpenShift can be an option for your container managed applications, and it has a service mesh capability to make those things communicate. But when you want to extend, what about the stuff that's not in OpenShift? It's apples and oranges to a degree, right? You wouldn't be making a decision one or the other. Be more like, oh, you're using OpenShift, well, we can plug into that and provide the discoverability and the cataloging of the services in a broader context.
Yeah. Thank you.
That's open source.
Thank you very much. I think this is pretty much it.
You guys hear me now?
Yes.
Yeah.
Yes.
Okay. There's one more question from Rob asking, with MuleSoft service, is Istio installed that will have to be manually updated or managed?
That is correct. We do not distribute Istio with the OpenShift's with the MuleSoft Service Mesh concept with the product. You are going to have to install Kubernetes. You're going to have to manage and maintain and update Istio. We will provide guidance in terms of what versions Anypoint Service Mesh to MuleSoft adapter works with, 100%. But yeah, so we're going to maintain that as we go along as well.
Okay, thank you.
Anything else, Mandy?
That was the last question. So yeah, thank you
For all your
Thank you,
thoughtful and insight. That helped a lot.
Yeah, does this cover your concerns in the beginning of the slide, Mandy, where you brought the implementer into view? So I guess we pretty much covered majority of the questions on that slide.
Everything and more, and I appreciate how you brought a lot of perspective to your answers. As with technology, a lot of the times there's never a black or white answer, but your guidance on how to leverage service mesh in the best way possible was very helpful, and I think a lot of our participants enjoyed listening to you guys speak too. So thank you for that.
I agree. Thank you very much, Matt and Ganesh. This was a really insightful presentation and demo as well. Now is the fun part. I think everybody's waiting for announcing the trivia winners. So I'll just go ahead. The first question was, in which API management capability category would you classify API documentation? And the right answer is B. And the winner is John Longarini from Core. Congratulations, John.
Yay!
Whoop, whoop.
Is he here? Like, I don't know.
I think he went to
He
another
went to a meeting.
I'll
No?
let
Okay.
Yeah, he had to drop.
Which of the following capability implementations is classified under API runtime management? And the right answer is A, API gateway. And the winner for this question is Alex Biglin. Congratulations, Alex.
clap. Virtual clap.
Last question. Which statement is not true about Anypoint service mesh? And the right answer is D. And again, we have another winner from Suncor Energy, Raj Krishna.
Very nice.
So 2 winners from Suncor Energy. Congratulations. I'll be talking to the MuleSoft meetup groups, announce the winners, and you should receive emails from the meetup group to just choose your courses. Congratulations for the winner, and thank you very much for attending and being here today with us. Again, thank you for our amazing speakers today, Matt, Ganesh, and Mandy. And thank you very much. Looking forward to have more of those meetups in the future.
Thanks, everyone.
Yes.
Take care.
Thank you.
Have a nice day.
Bye.
Cheers. Bye-bye.
Bye.